This is problem 7 from the first exam. So I've roughly reproduced the sketch of the graph that you were given. So we're given a graph of f prime of x, and we're first asked to graph the second derivative of this function. So let's try to do that. So there are some key points that were labeled on the original graph, so let's carry them down. Let's try to think about what's happening to the derivative of this function. So first of all, to the left of about -1, so this point here, the function is going upward. It's increasing. The slope of the tangent line is positive. So that means when we try to draw its derivative, the derivative should also be positive. So it does something like this. Then when it hits -1, or around there, we see that there's a horizontal tangent line to this function. That means the slope to the function there is 0, so the derivative must be 0. And then after that point, we see that the function is now decreasing all the way up till it reaches 1. That means that the derivative should become negative on that region. And then when it reaches 1, we again see there's a horizontal tangent line, so the derivative has to be equal to 0 wherever the function is a horizontal tangent. And then after 1, the function starts increasing again, so that means the derivative has to become positive. So we end up getting something that looks roughly like this. So now let's look at going the other direction. So we start with this graph that we're given at the top for f prime of x, and we have to try to find the graph of f of x. So how can we do this? Well, there's multiple possibilities because we don't really know what point the graph starts at. So let me just pick some point to start from, like here. And let's think about what this graph of the derivative is telling us. So up to this point here, so I'll try to bring that point down. So up to about this point here, somewhere a bit to the right of -2, the derivative was negative. That means that the original function must have been decreasing. And then at this point here, the derivative became 0, which means that the original function must have had a horizontal tangent. And then after that point, the derivative became positive again, so that means the function should start increasing. So it ends up doing something like this. That was not so great. So let me redraw this. So we have -2 here, -1 here, 1 here, 2 here. So it should end up doing something roughly like this. So we'll have a horizontal tangent line somewhere to the right of -2. Then it's increasing up until it hits 0, at which point, again, the derivative is 0, so that means it must have a horizontal tangent line there. And then the derivative becomes negative, so it starts decreasing again until this point here, slightly to the left of 2, where we get, again, a horizontal tangent line. And then the function starts increasing again. So it ends up looking something like this. This isn't the greatest drawing ever, but it gives you a rough idea of what the shape should be. The important things to capture, I think, are that wherever the derivative is positive, the function should be increasing. Wherever the derivative is negative, the function should be decreasing. And wherever the derivative is 0, the function should have a horizontal tangent line. And also, if we compare to the graph of f double prime, you'll see that we should have matched the concavity of this function as well. It's not so clear to see from my graph, I suppose. But it'll be concave up to around -1, then it switches to concave down. Then here it's concave down still for a bit until about 1, then it switches to concave up again.